All right, welcome to section 3.3. What we're talking about here is some of those properties of logarithms. So we talked about 4 of them in section 3.2. Now we're going to talk about a couple more and how we can use them to rewrite or simplify or expand logarithms. So the first property of logarithms is called the change of base formula. Change of base formula, so in 3.2, we talked about, just briefly, how to put something into a calculator. So if you typed in log in a calculator, it has an automatic base of 10. So what we're going to talk about here is how do we evaluate things in a calculator that have a different base. So we're going to let A, B, and C be real positive numbers such that A is not equal to 1. Ooh, I wrote that a little bit sloppy, I'm sorry. And B is not equal to 1. Sorry, let me just fix my own handwriting. There we go. Okay, this is a little bit better. Then log base A can be converted using any of the following formulas. So all of these formulas are going to be doing the same thing for us. Log base A of x, so if I have a base that is not 10, can be written as log base A, log base B of x over log base B of A. So if I have the logarithm of some base other than 10 of x, what I can do is take log base B of x over log base B of A. Essentially, I could rewrite that using any common number as the new base. Another way of writing this then is that the log base A of x can be rewritten as log base 10 of x over log base 10 of A. So in this case, I'm just saying, well, hey, I could rewrite it using any base, but how about I specifically rewrite it using 10? Because this would allow me to then type it into the calculator, because our calculator is in base 10. As well, if we have log base A of x, it's just another form of the same thing, we can also write that as natural log x over natural log A. And this again is for that same purpose of trying to put something into a calculator. So all we're saying there, and you'll see some examples. Actually, I'll stop talking because there are examples on the next page, and we are actually going to do them. There's not much notes in this section. So if I wanted to evaluate log base 4 of 18, the way that I could rewrite this using the change of base formula is to say that this is the log of 18 over the log of 4. And in reality, you can put any base under this log and this statement will be true, as long as the bases are the same. Now, the common one that you want is log base 10, because log base 10 is something I could put into the calculator. As a side note, though, log 18 over log 4, when log is written without a base, the way I have it currently written, that would mean that the base is an implied 10. So that's our change of base formula. That would allow me to now just type that into a calculator. Log base 5 of 20, that same idea. I can rewrite this as log base anything, but let's just say log base 10, so log of 20 over log of 5. Just to show, we could do this in a slightly different way. If we have log base 12 of 125, we don't even have to use log. We can use natural log and say natural log 125 over natural log 12. And again, that's something that I could just type into the calculator. Keep in mind that natural log of 125 is the same as log base E of 125. Log base E just means natural log. So that's why it's okay to do natural log for these, because they still have the same base of E. All right, moving forward. Some other properties of logs that we're going to need to know. We have 4 here. 3. I can't count or read, apparently. Log base A of U times V. So log base any number that isn't 1, of the product of two things. So sort of like how it works with exponents, when you have multiplication, you do addition. So if I wanted to split this, I can now rewrite this as log base a of u plus log base a of v. So I keep that same base, but now the way that logarithms work, one of the properties is that I can split this multiplication into addition. In the same way, if I have natural log u times v, it follows that same property, natural log u plus natural log v, because the base here is just specifically e. If I have log base a of u over v, again, thinking about the properties of exponents, division means that I subtract. So I would have log base a of u minus log base a of v. And the same thing with natural log of u over v is natural log u minus natural log v, because they have the same base. And last, and I don't want to say the most important, but definitely the one that people sort of struggle with at times, is log base a of u to the power of n. So a property of logarithms says that if your argument is raised to an exponent, that exponent can come down as a multiplier. So it becomes n times log base a of u. And same thing with natural log. If I have the natural log of u to the power of n, that n can come down and be n times natural log u. So those are just some properties, and what they allow us to do is simplify certain expressions, or on the other hand, expand them, so that we could, simplify at some point. So we're going to do a little bit of examples. This is going to be our last slide. Use properties of logs to rewrite. So we're using the properties to rewrite and simplify the logarithmic expressions. So I have log base 3 of 12. If I'm thinking about my properties, I'm thinking about this 12. By the way, if you were thinking about that circular motion or just what a log means, this means 3 to what power gives me 12, and that is not an integer. So that's why I want to rewrite this. So what I can do is say, well, 12 is the same as 3 times 4. I just rewrote 12 as 3 times 4, but for a reason, because I can rewrite this now using my properties as log base 3 of 3 plus log base 3 of 4. Log base 3 of 3, one of the properties of logarithms, or one thing that we learned, is when you have log base with an exponent, or I'm sorry, with an exponential function with the same base, those cancel. But they cancel in not just like a, hey, it's going to drop off the planet way. The answer to this is still 1. Because remember that what this is saying is 3 to what power gives me 3? Well, that's 1. Plus log base 3 of 4. Log base 3 of 4, there's nothing I can do to simplify that. So the only thing that this has done is sort of broken down log base 3 of 12 into a different format that is considered more simplified. Natural log 5 over e cubed. So division inside a logarithm allows me to rewrite it as subtraction. So natural log 5 minus natural log e cubed. Now natural log 5, there's nothing I can do with that. But natural log e, remember that natural log e cancels. So you could think of this as in one of two ways. I'm going to switch colors here. You can either think of this as the 3 is coming down, and I get natural log 5 minus 3 natural log e, which cancels. So I get natural log 5 minus 3. Or you can also think of the fact that natural log 5 minus natural log e cubed. I don't know what's going on with my pen right now, sorry. The natural log e just cancels, and I get natural log 5 minus 3. Remember that that exponent is just your answer, and this is the reason why, because it comes down as a multiplier. In terms of what I would love to see, this is way more like understanding of what is happening with those logarithms. One thing, sorry, final answer. Standard form, just -3 plus natural log 5. You know we always like the integer to come first. So this would be your final answer. All right, the examples video just covers those other 4 slides. I know I did some of the examples here, but that's because there's not really any new learning. I really do recommend looking at that though, because there's a lot of sort of cool stuff that goes on, and I'm hoping that it won't be too quick, but obviously I haven't made that video yet. Good luck.